Okay, so it's me, Moss, and welcome back to my channel, like Food with Moss. Okay, so basically, I come across a problem, which is this, which is a mountain, like find a peak index inside a mountain. I mean, a mountain looks like this. So the index is starting from this. I mean, like 0, 1, 2, 8, and then it's going to decrease the integers also, like 5, 4, 1, and 0, like something like that. So it's the mountain array. So we have to find the maximum integer number. Okay. So like overall that we have to find inside a integer what is the maximum number. Like that's okay. That's the whole problem. We have to find the maximum number inside an integer, and let's go that like let's jump into the problem on it. Okay, so basically this is the problem, whole problem, and we have to solve it. Okay, there's a peak, like a peak index inside a mountain array, so we have to found it. Okay, okay, so the what is the brute force approach that our Betty is going to think is basically what we can do is I think we can use a linear search, but the linear search is not going to work because it's like requiring a login. And how we can get a login? To get login, we have to use the binary search. And what are we going to here? The first of all, we're going to use a brute force approach, which is it's linear search. So then for int int, the I should be starting with 1, and the count is n from and okay, this is the loop. Let's run it. Okay, if you don't know how linear work, I mean how a linear algorithm work, so it's basically starting with 0, 1, 2, 3. Like it's going to check one by one, and it's not like the binary search. Binary search is basically divide those things. Like, do I wanted to check this part, like this 50% of part, or do I wanted to check this 50% of part? So it just work like that, binary search, but this is a linear search. So let's assume this is our array. So it's starting with index I means index 1. So this is like 3 number. So look, think of it, how we can get, like how we can check our maximum number inside a array. So to check that number, what we can do is basically check the right and the left part. Okay, let me give you a graph. I mean, let me give you an example. Okay, so let's just think this is our numbers. I mean, so right here, this is starting with 1 and 2, and then this is the 8 and 1 and 2. So to calculate how we can get the maximum value with if statements, so what we can do is basically compare our this number with this, the left value and the right value. If we compare the left and right value, if this is number is bigger than that, if this number is bigger than a left value and also bigger than right value, then it is the maximum number. So in here we're going to check this thing. If our array array of I minus 1 is greater than array of I, and array of I is also greater than array of I plus 1. So this is checking this array is and this array, like these two numbers are bigger than this index. If this is true, then we're going to just simply return I mean this is it, whole formula. And if this is not like if this loop is not going to run, then we have to like re, re return return minus 1. I mean this is it, like this is the whole problem. I mean, if you are able to understand, it's going to work, but the time complexity is like the big n. I mean the big n, but we need the time complexity of the log n. We don't need actually this thing, and we already approach it, but this is not the actual solution. We pass all test cases, but here you can see we want log n. To figure out log n time complexity, we want the binary search. Okay, how a binary search is going to work. Okay, so how a binary search work is binary search work like it's going to first of all find your, I mean, we have to define our starting and ending value of a array. Then after that it's going to find the mid index, and then it's going to think of it. Like we have to give the statements that if this is not true, then this half is the answer. So we have to think of that. So to think like that, what we can do? Okay, let's first of all create the basic, the boiler code of a binary search, which is int sta start is equal to one. I'm going to start with one because we want to check the that value and that value. We don't want to segment the value. Okay, starting with the one. Okay, so it just already giving us a hint. Okay, so inside a mountain array, the starting and the ending value is not the answer. It is giving us that starting and the ending are not the answer. So the answer is lie between the starting and ending. So we don't have to actually consider the starting and ending. So that's the reason I'm like int start is equal to one. The index number one is going to start with index number one. So int end is equal to n minus one. Let's just quickly says int n is equal to array dot size. Okay, this is good. So where to our while loop condition is should be st start is greater than and equal to end. I don't like actually this brackets aren't like this. Okay, so let's calculate mid and mid is equal to sta as rest divided by 2 semicolon. Okay, this is the formula of a mid. Now we have to check our statements. Okay, how we can check that thing? Okay, so in the first case, what are we going to think is basically whatever our mid value, let's suppose our mid value is 8. I mean, the mid value is 5. I mean, so is our 5 is the correct, the is our 5 is like right here, the 5 is going to store. So is our 5 is the answer. So to check that, let's read a if the same thing with array mid minus 1 smaller than array mid uh, and array mid is greater than array mid plus 1. This should be mid, and here we go. And if this is the answer, then we have to do nothing. It just like return. We have to just like return the mid value because this is the answer. And in the else if statement. Hmm. Okay, so inside this problem, there is a single thing what you guys can think is that the one part of array is already sorted. I mean, right here, I mean, this this array is sorted already. Like the, I mean, if we found the biggest value, then the smallest values are the sorted array, we can say. So in binary search, what we actually do is basically how we can iterate half of the array. We can half of the problem, how we can just don't even think like that is a possible answers. I mean, so let's suppose our mid value is 5. Okay, so what we can do is basically compare this mid value with the this number array. I mean, can compare this and this, and if this is our bigger, I mean if our middle value is bigger, then actually our array is increasing. It's not decreasing in truth, it's when it's increasing. So what actually we can do is basically convert our sets into this. Okay, let's think. So this is our main array. So this is our peak array. So we're going to convert. So we are going to convert this. So actually we're going to compare with our this number and with this thing. Okay, are going to compare left index with the peak index. So then if this index is bigger than this, so then our array is increasing. So then we can move our starting point to mid plus one right here. And it's going to again, it's going to loop. I mean, it's going to run a loop and it's going to count the mid value of the rest of the numbers. So then we already skipped the half of this array. So it's going to work like this. So let's just run it in a code. Okay, so like minus 1 mid minus 1 should be smaller than array of mid. If this is true, then what we can do in here is basically change the starting value to mid plus 1. Okay, starting value to mid, and the else condition, it should be else, yes, the else condition should be uh, end is equal to mid minus 1. Okay, here we go. And if those two conditions are not able to finish, then return n uh, return minus 1. Okay, here we go. Run it. It's going to pass all test cases. Here you can see 3 test cases are passed. Then submit. It's easily going to submit and with the 0 ms. And this is, and the time complexity is log n. If I can see the log n, I mean, definitely, yeah, the log n time complexity, because we use binary search, and this is how we can solve this problem. It took me decent amount of time. I mean, it took me decent amount of time to solve this problem, but it's worth it. I mean, we use binary search for that, and my Betty is totally able to understand the problem. So, bye bye. So this for the today's video. I hope you guys like this video. Like all things. Bye bye. Peace out.